Bismillahirrahmanirrahim. So, dear students, from today onwards, we will start new topic in your organic chemistry course. That is the amines in the organic chemistry. ठीक है, तो ऑर्गेनिक केमिस्ट्री में एमीन कंपाउंड्स को हम देखेंगे. तो आज हम बात करेंगे अबाउट द बेसिक्स अबाउट द एमीन्स, दैट इज इंट्रोडक्शन, देन सम स्ट्रक्चर, एंड जो इसमें जो इम्पोर्टेंट पोर्शन है दैट इज द बेसिसिटी. ठीक है, तो एज यूजुअल एट द एंड ऑफ दिस क्लास I will make these notes available for you. There will be a link in the description. You can download that and you can use it. ठीक है, so let's begin. सबसे पहले we'll begin with the amines introduction. Amines are basically organic compounds containing NH2 group. So those compounds which contain NH2 group, इनको हम कहते हैं organic chemistry में, they're called amines. Now they are also regarded as the derivatives of ammonia. So they are basically the compounds derived from ammonia in which one or more hydrogen atoms have been replaced by alkyl or allyl groups. यानी अमोनिया में जो ये दो हाइड्रोजन एटम्स हैं, you replace them one or two, replace them by alkyl group or replace them by aryl group, so you get amines. Then you get amines, they are called as 1 degree amines are primary, secondary and tertiary. So ये जो nomenclature है primary, secondary and tertiary, it depends on how many hydrogen atoms have been replaced. For example, यहाँ पे देख लीजिए डायग्राम में, this is ammonia. If you replace one of the hydrogen atoms by R, so it forms primary amine. If you replace two hydrogen atoms by R, R means alkyl or aryl group, so it's called as the secondary amine. And if you replace all the three hydrogen atoms in the ammonia by R group, so it's called as the tertiary amines. So this is the classification. Now दूसरे टाइप में हम देखेंगे तो amines can be aliphatic or aromatic. Aliphatic का मतलब ये जो R ग्रुप आपका है, it contains only aliphatic chain, CH3, CH2, इस तरह की chain present होगी वहाँ पे. So they are called aliphatic. For example, if it is CH3, it's called methyl amine. अगर यहाँ पे two hydrogens are replaced by two CH3s, it's called as diethyl amine. If three CH3s are present, it's called triethyl amine. If you have a long chain like this with three carbon atoms, it's called a propyl amine, yeah, propanamine. Aromatic amine means where you have this aromatic ring, benzene ring present. For example, this is the simplest one, it's called as phenylamine or common nomenclature aniline. Likely if you have this group present, this is the R group, benzyl group, so the compound is called as the benzyl amine. Now talking about its हाइब्रिडाइजेशन इन ज्योमेट्री, ये बहुत इंपॉर्टेंट एस्पेक्ट है एमीन्स का. एमीन्स की जब आप हाइब्रिडाइजेशन या ज्योमेट्री निकालोगे, सो दे आर द डेरिवेटिव्स ऑफ अमोनिया, सो द हाइब्रिडाइजेशन इज ऑटोमेटिकली sp3. व्हेन द हाइब्रिडेशन इज sp3, आप जानते हो द बॉन्ड एंगल शुड बी 109.28 डिग्री एंड द ज्योमेट्री शुड बी टेट्राहेड्रल. बट देन सिंस वी हैव वन लोन पेयर हियर, सो द ज्योमेट्री deviates from tetrahedral to it becomes pyramidal. This is the pyramidal geometry. अब चूंकि लोन पेयर प्रेजेंट है यहाँ पे, so the bond angle gets reduced, so it becomes 104 degree. So this is the pyramidal geometry of 1 degree, 2 degree and 3 degree amines. Now अब इसका जो important aspects जिसमें एग्जाम्स में क्वेश्चंस आते हैं, कॉम्पिटिटिव एग्जाम में क्वेश्चंस आते हैं, that's the basicity. Now in the amines अभी हमने देख लिया that you have this nitrogen group present, while you have a lone pair present here. Now lone pair present has, that means it can be donated. So those compounds which can donate a lone pair, so they are Lewis bases. So the amines act as Lewis bases. इनकी basicity हम understand कैसे कर सकते हैं? We have to understand the inductive effect. देखिए, now this is primary amine, this is tertiary amine, this is secondary amine, this is primary and this is ammonia. Now here we have a lone pair, there also we have a lone pair, and here also we have a lone pair. Now this lone pair can be donated, so amines are bases. Ammonia is a base. Likely primary amines are bases. Then secondary amine B, they will act as bases, and tertiary amines also act as bases. अब इनमें से strong base कौन है? As per the inductive effect, इस पे जो R group attached है, इस पे जो group attached है, ये जो these R groups are normally aliphatic groups. They are electron donating. They have plus I effect. So when they donate the electrons, so the electron density on the nitrogen increases. So turns out that tertiary amines are stronger bases than secondary, then primary, then ammonia. तो हम order ये लिख सकते हैं, tertiary amines are stronger bases than secondary, then primary. लेकिन यहाँ पे important बात हमें याद रखनी है कि ये जो order of basicity है, it is in the gas phase. Gas phase means आपका जो ammonia है, आपका जो amine है या derivative of amine है, it is present in the gas phase. तो गैस फेज में आप ये ऑर्डर लिख सकती हो. क्यों? व्हेन यू लुक, अगर आपका अमोनिया सोल्यूशन में हो, यानी अगर आपका एलिफेटिक अमीन हो या जो भी अमीन आपका हो वो सोल्यूशन में हो, देन द ऑर्डर इज दिस वन. 2 degree is a strong base, then 1 degree, then 3 degree. So this order is actual order which is in the gas, this is the liquid aqueous phase. यानी आपका अमोनिया or the derivative of ammonia or any amine, it's present in the solvent which is water. ऐसा क्यों होता है? टू अंडरस्टैंड दैट, देखिए जब भी अमोनिया एक्सेप्ट्स डोनेट्स अ लोन पेयर, फॉर एग्जांपल दिस अमोनिया इट डोनेट्स अ लोन पेयर, और हम ये कहेंगे कि इट एक्सेप्ट्स H+. तो अमोनिया इज अ बेस सिंस इट डोनेट्स दिस लोन पेयर, और हम ये कह सकते हैं कि इट एक्सेप्ट्स द H+. हम जानते हैं दोज केमिकल स्पीशीज व्हिच एक्सेप्ट द H+, दैट इज अ प्रोटॉन, सो दे आर कॉल्ड एज ब्रॉन्स्टेड बेसिस. तो ammonia acts as a base because it has a lone pair. So in that term it's a Lewis base, but since it accepts a proton, so it's a Bronsted base. ठीक है? तो जब ये base act करेगा, then it has a proton. This is the structure. And in case of secondary, this is how the structure looks like. This is how the structure looks like. And in case of primary, this is how the structure looks like. यानी ये जो structure बन गई after acceptance of H+, it's called a conjugate base. The conjugate base में ammonia has this amines have a plus charge, so this will get balanced, this will get stabilized by the polar water molecule or the solid molecules directly stabilized by these. अब यहाँ पे जो stabilization, this is more stronger in case of primary, because primary में bulkier groups, R group is a bulkier group, so primary में bulkier groups less है, so more water molecules will stabilize this base. When the conjugate base becomes stable, that automatically means कि ये जो इसका जो सोर्स था, यानी इसका जो ओरिजिनल बेस था, दैट इज मोर स्ट्रॉन्गर. तो कहने का ये मतलब है, सिंस 3 डिग्री अमीन्स जो है दे आर हाईली स्टीरिकली क्राउडेड, तो ये जो बेस, ये जो केटाइन है, इट्स नॉट गेटिंग स्टेबलाइज्ड दैट मच इन द सॉल्वेंट, सो it behaves, the result is that it's a weaker base, while as the stronger base is 2 degree. क्योंकि 2 डिग्री में दोनों फैक्टर डोमिनेट करते हैं. एक, इसमें स्टेबिलिटी भी ज्यादा है, स्टेबिलिटी ऑफ इट्स कैटाइन, एंड एज वेल एज इसमें 2 डोनेटिंग ग्रुप्स भी है. यहाँ पे 3 डोनेटिंग ग्रुप्स है, लेकिन स्टेबिलिटी फैक्टर लेस है. तो दैट्स व्हाई लुकिंग एट बोथ दीज फैक्टर्स, वन इज द स्टेबिलिटी ऑफ द अमोनियम कैटाइन एंड द स्टेबिलिटी एंड द इलेक्ट्रॉन डोनेटिंग ग्रुप्स, वी हैव दिस ऑर्डर व्हिच इज एक्चुअली प्रिवेलिंग in the aqueous phase, that 2 degree amines are stronger than 1 degree than 3 degree. फिर उसके बाद अगर हम aromatic amines की बात करते हैं, aromatic amines are less basic than aliphatic. Reason, क्योंकि aromatic amine जो आपका simplest है, this is your simplest aromatic amine, it's called aniline. ये जो lone pair है जिसकी वजह से amines are bases. Now it is involved in the conjugation. So when it is involved in the conjugation, it means it is not available for the donation, or it is less available for the donation, because you can see here in the different canonical structures we have a plus charge, so it is not available for donation. और ये कह सकते हैं it is less available for donation, means that it's a weaker base. So aromatic amines are less basic than aliphatic amines. So this is all what we had today from the first class of our amines, as the introduction, structure and basicity. I will go to the important portion again. Basic amines are bases because they have this lone pair which is available for the donation, okay? Which is available for donation. Now we have 1 degree amine, 2 degree amine, 3 degree amine, depending on how many R groups are there. Among them, if we look at this inductive effect point of view, इसके हिसाब से अगर हम देख ले, then 3 degree amines are more stronger bases than secondary, than primary. लेकिन this is only possible in the gas phase. If we look at the stability, if we look at the stronger basicity in the aqueous phase, then order is 2 degree, 1 degree and 3 degree. Reason, when the amine, it accepts a proton, then जो conjugate इसका species बनता है, जो ammonium cation बनता है, it is stable इट स्टेबिलिटी प्लेज एन इंपॉर्टेंट रोल. इसकी जो स्टेबिलिटी होती है, इट गेट्स स्टेबलाइज्ड बाय द सॉल्वेंट मॉलिक्यूल्स दैट द वाटर मॉलिक्यूल्स, एंड द स्टेबिलिटी इज मोर इन द प्राइमरी देन इन द सेकेंडरी देन इन द टेरिशरी. तो दोनों फैक्टर को हम जमा करते हैं, इंडक्टिव इफेक्ट एंड द स्टेबिलिटी ऑफ द अमोनियम कैटायन, इट टर्न्स आउट दैट इन द एक्वस फेज 2 degree amines are more strong, they have more strong bases, ठीक, than primary than tertiary. तो ये दो ऑर्डर्स है गैस फेज में. गैस फेज में you have this tertiary, secondary and primary, while as in the solvent aqueous phase it is 2 degree, 1 degree and 3 degree. And then in the end aromatic amines are less basic, their basicity is less as compared to aliphatic amines. Reason, because we have resonance there and the lone pairs involved in the conjugation, it is not easily available for the donation. तो ये आज का हमारा क्वेश्चन था. तो अगर आपका कोई भी जो है इसमें कोई भी आपका कॉन्सेप्ट है, इफ यू डिडंट अंडरस्टूड दैट, कोई भी आपका कंफ्यूजन है, तो यू कैन राइट डाउन. सो आई विल बी देयर टू आंसर दैट. So in the next class now we have the important naming reactions in the amine portion of your syllabus. So this is all from the day. Thank you.